Good morning everyone. Welcome to Computer Lab Space. Watch my previous videos on C programming for better understanding of basic C concepts. Today we will learn bitwise operators. We have already studied different types of operators, right? Arithmetic operators, logical operators, relational, then assignment operators. We have already studied. Then today we are learning with bitwise operators. Here bitwise is nothing but we are going to dealing with the bits. We are trying to manipulate the bits. So that's why we call it as bitwise operators. Okay. So we have one minute. Okay, we have bitwise and bitwise or, then negation, that is bitwise exclusive or, then this symbol we call it as caret symbol. Then negation we have, that is one's complement, then left shift, right shift. Okay. So for the bitwise and, for example, if the corresponding bit positions in both the operands are 1, then the result will be 1. So that is what bitwise and. Here for an example, I have taken the truth table P, Q, and as like similar to our truth table, I have mentioned the values 0, 1, 0, 1, 0, 0, 1, 1. Then P, bitwise and Q. So in the bitwise and, when both are 1, the result will be 1. Otherwise it is 0. Then for the bitwise or, if neither of the one bit is 1, the result will be 1. Otherwise it is 0. So for both zeros we have 0. And here one bit, either of the two operands, one bit is 1. So the result will be 1. And for the exclusive or, see here we have the value for 0, 0 also it is 0, and for 1, 1 it is also 0. So why? Because the bitwise exclusive are, in this we are going to consider the corresponding bit positions in both the operands. The corresponding bit position in both the operands are different, then the resultant value will be 1. If the corresponding bit position in both the operands are same, the result will be 0. It is easy to remember like this. When both the operands values are same, the result will be 0. If both are different, the result will be 1. Okay, so this is what exclusive, bitwise exclusive are. Then we are going to take with the example. Generally in internals or in the external exam, the question can be asked like this. Assume A is equal to 60 and B is equal to 13 in binary format. That means we need to convert this decimal value into binary value. Then we are going to perform the action, whatever it is, bitwise or, bitwise and, or bitwise exclusive or the negation of one's complement. So these actions we need to perform on the binary form. Okay, so first let us convert. How we are going to convert that decimal form into a binary form? We are going to divide it by 2. So 2 3s are 6, 0, and the remainder is 0. Then 2 1s are 2, then 1 carry, 2 5s are 10, it is 0. Then 2 7s are 14. So 15 minus 40 means 1, 1 left out. Then 2 3s are 6, 1. Then 2 1s are 2, 1. So while writing the binary form, we need to write from down to upwards. Okay. So the value will be like 1, 1, 1, 1, 0, 0. We need to convert that into 8 bit, okay, or 1 byte. 1 byte is equal to 8 bit, right? So we have 6 bits here. The remaining we need to append it by 0 at the back side or on the left side. Okay, so now it is 8 bit. So that is what I have written here, 0, 0, 1, 1, 1, 1, 0, 0. So we are going to write like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Why I am writing, I will tell you. 2 power 7. And whatever you have converted no, to the binary form, you can also cross verify whether the value is, whether the binary form is right. Okay. So that you can do it by 0 into 2 power 0 plus 0 into, see, 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3 plus 1 into 2 power 4. You are going to get the value 60. You can continue. 1 into 2 power 5, 0 into 2 power 6 plus 0 into 2 power 7. The result value should be equal to the decimal value, that is 60. Similar way I have done for the 30. Now, just perform a bitwise OR operator, sorry, bitwise AND operator for this two operands. So we already know, right? For the bitwise AND, I don't repeat that. So the value you are going to get for if the if the corresponding bit position in both the operands are 1, then the AND operation results in 1. Otherwise, it is 0. So if you check here, both the values, both the corresponding position values, bit position is 1, then the result is 1. Otherwise, it is 0. For the bitwise OR, if any one, the value is 1, then the result will be 1. So if check here, 1, 0, it 1, then 1, 0, 1, then 1, 1, it is 1. Yes. So I hope you got it. Then exclusive OR. In the exclusive OR, as I explained, when both the values are different, you are going to get the value as 1. Otherwise, it is 0. If you check here 0, 1, both the bits are different, so you're going to get the result as 1. Then complement. Complement or negation you can perform on a single operand because that is a unary operator. So negation of A, the reverse of. So 0, if it is 0, it is 1, or if it is 1, it is 0. So you're going to get this result. And the most importantly, we have six operators, six bitwise operators, right? So bitwise AND, bitwise OR, bitwise exclusive OR, and then negation. 4 over. We have left out with left shift, right shift. The next slide, right shift operator. So as like before, we are going to take x value or a value is equal to 60 only. Okay, I already show how to convert that, right? So right shift operator, generally they are going to give it as like a is equal to a, right shift, how many times you need to shift, sorry, how many bits you need to shift or how many times you need to shift, that is going to be mentioned here. So I am going to take it as 3. Okay, 3 times shifting. Shifting, it is nothing but since it is a right shift, you are going to shift this bit to the right side. That means you are going to ignore this, ignore this. For the first, if you are familiar with the shifting, you can directly write the answer by ignoring the right 3 bits and you're going to get the answer as 11100 and you're going to append it by 00 to make it 8 bits. Okay. Otherwise, if you're not familiar or if you feel confusing, you can shift one by one till you reach till you perform 3 shifts. So I'm just going to show 0. You are going to ignore this. Then you are going to shift each bit to the right side. So what the value you are going to get 0, 1, 1, 1, 1, 4 ones, right? Yes, 0, then 0, 0. This is what our first shift. This is what our first shift. And for the second, then third shift. So for the second shift, you are going to perform the shift for your first shift only. So you're going to ignore this and you're going to left with 1, 1, 1, 1. Then 0, 0, 0, 0. Similar way, you're going to ignore this bit and 1, 1, 1, 0, 0, 0, 0, 0. And sometimes they are going to ask after performing 3 shifts, what will be the decimal value? If that is the question, you need to calculate similarly as I already told. You are going to perform 2 power 0. That is 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2. The rest you can ignore since it is 0 into 2 power 3. You can ignore this. So you are going to get 2 power 0 is 1. So 1 into 1 it is 1 plus 1 into 2 power 1. 2 power 1 it is 2. 2 power 2, 4. 4 into 1 is 4. So you're going to get the value as 7. So this is what the final answer you need to write when they asked in the exam. Either it is the right shift or the left shift. Similar way for the left shift you need to ignore the left side operand whatever you are having, right? So here you are going to ignore this. So the remaining you are going to write 0. Here also you need to consider for the 8 bit only, whatever the value is. 0, 1, 1 1 1 0 0 0. Going to shift the second shift, again you are going to ignore this bit, so you're going to left with 1 1 1 1 0 0 0 0. Okay, the remaining bits you need to append by 0. Then after third shift, after shifting thrice, so you're after shifting thrice or while shifting here, you're going to ignore this bit, the remaining you're going to get with 1 1 1, and then you're going to append this by zeros. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Here it is 1 into 2 power 5 plus 1 into 2 power 6 plus 1 into 2 power 7. You calculate this and you're going to get the final decimal value for the left shift, or after performing three shifts, that is left shift. Is it clear? So this is what the right shift and the left shift, which includes in the bitwise operators. And the most general or normal question can be asked, like whether the negative values we can able to perform right shift or left shift. No, for the negative values we are not going to perform this action, whether it is a bitwise and bitwise or exclusive or it is a negation or right shift left shift, we are not going to perform for the negative values. That is the most common question generally asked. And even the one more interview question, it is like which among this, which operator is useful, that is bitwise exclusive or is useful. I hope the concepts are clear. Hope you like this video. Thanks for watching. We will see you all in the next video, that is for the increment decrement operator. Thanks for watching. If you like the video, click on like, subscribe and bell icon for the notification. Thank you.